Genetically modified foods have become an integral part of the global food supply, shaping not only our grocery store shelves, but also the way we think about agriculture and the future of food. At its core, genetically modified food, often abbreviated to GM or GMO, refers to any crop or organism whose DNA has been altered using modern genetic engineering techniques. This scientific approach allows researchers to introduce, enhance, or remove specific traits within a plant or animal, often to improve yield, enhance resistance to pests or diseases, boost nutritional content, or even withstand environmental challenges such as drought or extreme temperatures. The journey of genetically modified food began in the 1970s, when scientists discovered how to transfer genetic material between organisms. The first genetically engineered plant, an antibiotic-resistant tobacco, emerged in the early 1980s. This paved the way for the commercial introduction of genetically modified crops in the 90s. The United States was among the first countries to widely adopt them, starting with crops like soybean, corn, and cotton. Since then, the adoption of GM foods has spread worldwide, though acceptance varies significantly depending on the country or region. Why genetically modify food in the first place? Traditional breeding methods, cross-pollination, selection, and hybridization, have shaped crops for centuries, but these processes are slow and sometimes unpredictable. Genetic modification accelerates and refines this process. For example, inserting a specific gene borrowed from a bacterium into a corn plant can make the corn inherently resistant to certain pests, reducing the need for chemical pesticides. Similarly, adding genes that confer drought tolerance can help farmers maintain yields even during seasons of low rainfall. Some of the most common genetically modified crops include soybeans, corn, canola, and cotton. These commodities are used not only as food, but also as ingredients in countless processed foods. If you've ever read labels and spotted ingredients like corn syrup, soybean oil, or lecithin, there's a good chance these are derived from genetically modified crops, especially in countries where GMOs are widely grown. One of the most famous examples of a genetically modified food is golden rice. Regular rice, though a staple for billions of people, lacks beta-carotene, a precursor to vitamin A. In developing countries, vitamin A deficiency is a leading cause of preventable blindness and increases the risk of infectious diseases. Scientists developed golden rice by adding just a few genes so the rice plant could produce beta-carotene in its grains. The goal was simple: help to reduce vitamin A deficiency among populations relying heavily on rice as their main food source. Genetically modified foods don't just benefit consumers and large-scale agriculture. They also provide advantages to farmers. Crops engineered to resist insects or tolerate herbicides can reduce the time and cost associated with crop management. This often means using fewer chemical sprays, which is better for the environment and for people living near farmlands. Drought-tolerant crops help stabilize food supplies in regions impacted by changing climates, providing more consistent yields even when weather patterns are less predictable. Despite their advantages, genetically modified foods remain a subject of debate. Supporters argue that GMOs are crucial for feeding a growing global population, making agriculture more sustainable, and even reducing the environmental footprint of farming. They cite years of scientific research showing that approved genetically modified foods are as safe to eat as their non-GM counterparts. On the other hand, critics raise concerns about environmental impacts, potential health risks, and economic issues. There are fears that genetically modified crops could crossbreed with wild relatives, potentially disrupting local ecosystems. Others worry about the long-term health effects, even though major scientific organizations, including the World Health Organization, agree that GM foods currently approved for sale are safe to eat. There are also concerns about the control of agriculture by a handful of large corporations that own the patents and intellectual property associated with genetically modified seeds. Regulation of genetically modified foods varies widely from country to country. The United States, for example, has largely embraced GM crops, with minimal labeling requirements. In contrast, the European Union has stringent requirements for testing and labeling, and several member states have banned the cultivation of GM crops outright. This patchwork of rules reflects cultural attitudes, consumer preferences, and different levels of trust in regulatory systems. Beyond traditional crops, genetic modification is also making its way into livestock and aquaculture. In recent years, genetically modified salmon that grow faster than conventional salmon became available for commercial sale in certain markets. There is ongoing research into livestock with improved disease resistance or with altered metabolism to reduce environmental impacts like methane emissions. Looking ahead, genetic engineering is entering a new frontier with a technology called CRISPR. Unlike earlier methods, which could only introduce new genes, CRISPR allows scientists to make precise edits to an organism's own DNA. This opens up possibilities for crops that are more nutritious, flavor-rich, and resilient, all without necessarily introducing foreign genes. For instance, researchers are developing tomatoes that stay fresh longer, wheat that resists fungal disease, and bananas resistant to devastating viruses. As genetic modification technology advances, the global conversation around it will no doubt continue to evolve. There are questions not only about safety and labeling, but also about equitable access to these innovations, the protection of biodiversity, and respect for cultural preferences in what people eat. In the end, genetically modified foods represent both the promise and complexity of modern science. They offer tools to address hunger, improve nutrition, and make agriculture more sustainable in the face of a changing climate. At the same time, they challenge societies to balance innovation with caution, freedom of choice with collective responsibility, and the wisdom of tradition with the potential of cutting-edge science. As we move forward, the choices we make about genetically modified foods will shape not only the contents of our plates, but the future of food for generations to come.